In this lecture, we shall give introduction about capacitor. First of all, I shall define capacitor and then I shall explain it. The definition of capacitor is that a capacitor is a device that can store electric charge. How an electric charge is stored in capacitor, I shall explain it in next lecture. In this lecture, I shall give the basic introduction of a capacitor. So, capacitor is a device that is used to store electric charge. Now we talk about the construction of a capacitor, or we can say that we shall talk about the geometry of a capacitor. So, a capacitor consists of two conductors, and the two conductors are placed near each other. It is a very simple device which consists of only two conductors, and both the conductors are placed very close to each other. And the conductors are separated by vacuum. Vacuum means there is no medium between the conductors. The space between the conductors is empty, that is vacuum. Or there can be air between plates, between conductors, or there can be an insulating material or insulator material, and that insulator material which is placed between the two conductors is called dielectric. So this is a very simple device consisting of only two conductors, and both the conductors are separated by vacuum, which means there is no medium between plates, or there can be a medium, and medium can be air or an insulator material, and that insulator material is called dielectric. Now we talk about the shape of conductors, and we name it as the geometry of conductors. Are the conductors in the form of a rod? Conductors are in the form of a plate, in the form of a cylinder, or which type of shape the conductors have? So depending upon the geometry of conductors, we can name a capacitor. We can make different types of capacitors. If the conductors are in the form of plates and the plates are parallel to each other, then we name the capacitor as a parallel plate capacitor. And if the conductors are in the form of cylinder, we name the capacitor as a cylindrical capacitor. And if the conductors are in the form of sphere, we name that capacitor as a spherical capacitor. So depending upon the geometry of conductors, we can name a capacitor according to the geometry. And the ability of a capacitor to store charge depends upon the geometry. which we shall discuss later. Presently, I shall discuss a parallel plate capacitor. A parallel plate capacitor is defined as if the conductors are in the form of parallel plates, then the capacitor is called a parallel plate capacitor. Depending upon geometry, we have named this capacitor as a parallel plate capacitor. A parallel plate capacitor is shown in the figure below. So to show a parallel plate capacitor, let this is one of the conductors and this is the second conductor. Both the conductors are in the form of plates having width and length in this form. These are placed parallel to each other. Suppose these are two plates and both the plates are parallel to each other. I have uh, these two lines also show both plates, and if the plates are connected with a battery with a voltage source, one of the plate is connected with the positive terminal of battery and the other plate is connected with the negative terminal of battery. So first of all, suppose this is the parallel plate capacitor. This is one of the plates and this is the second plate, and this is battery of voltage V. So now we talk about what happens when we connect these two plates with a battery. When the plates of capacitor are connected to a battery of voltage V, the battery places a charge plus Q on the plate connected to its positive terminal, and battery places or deposit charge minus Q on the plate connected to its negative terminal. The amount of charge on both the plates of capacitor is same. The magnitude is same, but the sign of charge is different. The plate which is connected with positive terminal has positive charge, and the plate connected to negative terminal of battery has negative charge on it. Due to this positive and negative charge on plates, there exists electric field between plates, and the direction of electric field is from positive to negative terminal of battery. And there also exists a potential difference between plates due to positive and negative charge on plates. So now we further discuss that how much charge will be placed on the plates of a capacitor. The amount of charge on the plates of capacitor depends upon the voltage of battery. So first I mention here the charge on positive plate is plus Q and the amount of charge on negative plate is minus Q. It is observed that if charge Q is on either of the plates, it is observed that the charge on the plates is directly proportional to the potential difference or the voltage of the battery. And one more thing is that the amount of charge on both the plates is equal. Positive charge on one of the plates, the amount of positive charge on one plate is equal to the magnitude or amount of charge on other plate. Only the difference is the difference of sign, positive and negative charge. So the magnitude of charge on either of the plates is directly proportional to voltage of the battery. And from here we can write as in the form of equation Q is equal to CV. Q is amount of charge, V is potential difference, and here this constant of proportionality C is called capacitance of capacitor. This C is the proportionality constant. This is the capacitance of capacitor. Now we shall define the capacitance of capacitor, and we shall also see the factors on which capacitance depends. The capacitance of the capacitor is defined as the ability of a capacitor to store electric charge is called capacitance. The capacitor which can store more charge has greater capacitance, and a capacitor that can store less amount of charge has less value of its capacitance. So capacitance is basically the measure of ability of a capacitor, that how much charge a capacitor can store on its plates. We can define the capacitance as one more way to define the capacitance is the amount of charge on one plate amount of charge on one plate necessary to raise the potential of that plate by 1 volt with respect to the other plate. The amount of charge on one plate that is required to raise the potential of that plate by 1 volt means the charge on the plates produces a potential difference of 1 volt between plates. That amount of charge that is stored on the plates is called capacitance. If more charge is required, if amount of charge is greater means more charge is required. If greater amount of charge is required to produce 1 volt potential difference between plates, then capacitance has high value. And if less amount of charge is required to produce potential difference of 1 volt, then that capacitor has less capacitance. That capacitor can store less amount of charge. Now we talk about the unit of capacitance. The unit of capacitance is Farad. SI unit is Farad, and 1 Farad is equal to, from the equation above we can see that capacitance C is equal to charge per unit potential difference. As we know that charge has unit of coulomb and potential difference has the unit of volt. So capacitance is defined as coulomb per volt. This unit of capacitance coulomb per volt is called Farad. So the unit of capacitance is Farad. Now we define the unit Farad. It is defined as if a charge of 1 coulomb is given to one of the plates of a capacitor, and it produces a potential difference of 1 volt, then capacitance of capacitor is 1 farad. This definition of capacitance and the definition of farad are almost similar. So farad is defined as if a charge, this amount of charge, if a charge of 1 coulomb is given to one of the plates of capacitor, and this charge on plates of capacitor produces a potential difference of 1 volt, then capacitance of capacitor is 1 farad. So this is the definition of SI unit of capacitance, which is farad. Now we see that the factors on which capacitance of capacitor depends. Dependence of capacitance on the factors. It has been observed that the capacitance of a capacitor depends upon geometry of plates, on area of plates. Capacitance also depends upon separation between plates, and capacitance also depends upon medium between plates. So we shall discuss all these factors in the next lectures. In this topic, I have given you the basic introduction of a capacitor. And capacitor, we have seen that capacitor is a very simple device that is used to store electric charge, and it consists of just two conductors, and the conductors are separated by air, by vacuum, or any other insulating material. In the next lecture, we shall discuss the capacitance of a parallel plate capacitor.